That's the thing, he was like,
Okie dokie.
So I'm gonna record today. So if I start to get up and do this, remind me that I'm recording. So, because this is like the review, right, for the final, and I wanna give you guys a chance to ask questions about the final, but I want the online people to get all the same information that you get. So we're recording so they can hear your questions and hear my answers, they just can't see you guys, all right? So, are there any questions, like logistic questions, that you have about the final? Kylie, can you see up there? Am I like all in?
Yeah,
Mostly this is what I'm worried about.
about here up.
Oh, that's fine. Okay, so. No questions for Rick?
I had a question about, I don't even know how to say it,
Gauss's method.
Yeah.
There, I just finished writing the Gauss's method problem, but it's on the bonus section. So I would be more than happy to do one for you now if you like. But I did move that to the bonus section out of the main problems. So, your call. Taylor, did you say something back there? I'm sorry.
No, we're just talking.
No, we're just chatting.
Okay.
Oh, I have all the questions. I'm gathering them in my brain.
Okay, but I thought you said something about bonus.
Oh, I said, is there a bonus?
There is a bonus section. It has 4 problems on it, which would be worth a total of 20 points. I try to be generous. I try to be compassionate
Gauss's method for
at
sure.
final time. Amy, what
When
did you
it
have?
says
to-
like find 75% of 60,
Okay.
like how do we get to it?
Do you remember doing it when we were in the computer lab last week on
I
Friday?
remember, I don't know if you were here.
I wasn't here.
That's why you're having trouble with it. I think I have one coming up, let me see. It's kind of like that. What's this one? No. Hold on and I will pull one like that up, okay? Because there's a string of them. If you look at, let's see, I think I have it over here maybe, no. There's a string of them on the review.
Yes, that's what I was thinking.
And we, right here. We did them in class on Friday. And I always put a question like that on the final. So it's a string of easy points if you know your mental strategies that you boom, boom, boom right away. If you don't know your mental strategies and you go off to the side and you have to do all those calculations, you're gonna run out of time. So what you wanna do with these is we almost always start with either 10 or 50% because no matter what this number is right here, I always make it a nice number. You can find 50% of something, right? Just cut it in half. Or we can find 10% of something, right? We just move the decimal one time. So once you have 10, you can pretty much build everything else from that. So I know 10% of 60 is 6. So from 10, I could say, okay, 5% is half of 10. So this should be half of 6. Does that make sense? So to get, say, 15%, 10% plus 5% make 15%. So 6 plus 3 is how I get 9. Does that make sense? All right, so then you got 10, you got 5, you got 15. Look, at 25, you could use 2 10s and a 5 to do it that way. You could take your 50 and cut it in half and do it that way. There's lots of different ways to do that, but the key is start with 10 and then build up and down from there using multiplication addition. I always put one like this on there. It will either be 33 1/3 or 66 2/3. 33 1/3% is just what? A third of it, right? So you take whatever the number is and divide by 3, because 33 1/3% is just a third of the whole. So 60 divided by 3 is 20. If it were, if on that one I had asked for 66 2/3%, that's 2/3. So you divide it by 3 and get the 20, but then take 2 of those 20s. So 66 2/3% of 60 would be 40. You take a third and then you have 2 of them. Does that make sense? Okay. So those are the mental strategies, and it's like one question, like say question 41, and it's A, B, C, D, E, F, like that, and it's just boom, 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 boom. Okay. Other questions about refinement?
I have a question.
Yes.
It's from unit 6.
Uh-huh.
It says, using the method we discussed in class, add the following mixed numbers without changing the mixed numbers to improper fractions.
I did not put one of those on there.
Okay, another question. Another time out.
So I'm,
Oh, can you go over one where you have to do like the equivalent fractions, like 4 equivalent fractions, like one larger denominator, and one smaller?
sure, let's see if we can, see if it pulls up in here. Convert to decimal, rational. That's, no, cause that's all gonna be fractions. Okay. So you wanna give me a fraction, or do you want me to pick one? Doesn't matter. Do you wanna give me the fraction, or?
15/20.
Okay. So, here I'm trying to figure out if you can find equivalent fractions. Equivalent fractions are worth the same amount, the same value, but they look different. We're just scaling up or scaling down the numerator and denominator, which is what we use whenever we have to find common denominators. We're trying to find equivalent fractions. So, you can do it multiple ways, but to get a smaller denominator, I don't want to put that divide there. To get a smaller denominator, we could say, let's decompose. Can we decompose 15 and 20 into factors? Like with a common factor, what could we use? 5. So I could use 5 times 3, and the denominator would be 5 times 4. That gets me a special what? That special 1 right there that I can get rid of. So my equivalent fraction is 3/4. So there's one equivalent fraction. 15/20 is the same as 3/4. There's my one with a smaller denominator. Says I need one with a bigger denominator, right? So instead of decomposing it, I could multiply by 1. Any one I choose, I'm going to choose a special one, like 5/5. Still 1, right? So I'm not changing the value of it. That gives me 75/100. So there's an equivalent fraction with a bigger denominator. And you can use any of those 3 and divide up or multiply, or divide down and multiply up and get more equivalent fractions because they're all equal. So I could take this one, 75/100, if I wanted to. Let's multiply it by another 1. That's still 1, right? So that's what, 150/200? There's another one, a bigger one. Make sense? Okay.
Is there one where you give us 2, and then we have to find, or,
Where you have to find in between.
yeah, and you were talking about, like, adding or something?
I don't remember if there's one like that on there or not, so I'm gonna go ahead and do it, okay? So, suppose you have 2/3 and 4/5, and I asked you to find me two fractions that lie in between them, okay? What I don't want you to do is estimate everything with a decimal and say, okay, this one is 0.6666 and this one is 0.8, and then try to come up with a decimal and then go back to a fraction. All you're doing right there is showing me that you can't work with fractions. You only feel comfortable with decimals. That's not what you want to do on a test, is show me that you're not comfortable with something, right? You want to show me that you are confident with fractions, because that's what I'm testing. So, if we were doing this for our littles, in middle school, there's two ways to do this, right? There's the middle school way, or upper elementary, the way we teach it, and then there is a shortcut theorem way that I taught you in this course. So the middle school way says, okay, first thing we need to do is we need to come up with a common denominator so I can compare them, right? What would my common denominator be between 3 and 5? 15. So I'm going to rewrite this one as 10 over 15. I'm going to rewrite this one as 8 over 15? No, 12 over 15. Thank you. I was like, wait a minute. All right. So I can see right there that there is one number between 10 and 12. So I could get another, I could get 11 over 15. I know that belongs in the middle there. But there's nothing else between 10, 11, and 12 in the numerator. So I need to scale it up again. I always taught my littles, why scale it tiny bits and have to keep doing the work over and over and over? Let's make the next jump big. Let's scale it up by 10 over 10. We'll multiply everything by the special one, 10 over 10, which gets me 100 over 150, 110 over 150, 120 over 150. Now, could I pick some extra numerators in here between 100 and 110, or 110 and 120? Can I fit more in there? Sure, I can now, right? I could fit anything in here. 105 out of 150. I could fit 115 out of 150. Those all fit in between there. We good with that? That's the middle school way, how we teach them to reason it out using equivalent fractions. There is a theorem that I taught you in this class that says if you have any two fractions, like 2/3 and 4/5, you can simply add the numerators and add the denominators, and this new fraction, size-wise, will lie in between these two. Okay? So if I wanted to do another one, I could just use these two fractions and say, okay, then 10 over 13 must lie between these two. So that's just a short way. As a teacher, we can find quickly when we're doing examples and things on the board. If I need to find one in between something, that's a way I can do it really quick. Okay, you guys don't have any more like formatting questions? I will tell you, I did get a question about like what does it cover? The final covers technically 6 and 7, right? Fractions, decimals, and percents. But by the nature of number, once something is introduced to you, then from then on you know it. So since we did integers back in 5, there is the possibility you're going to see signed numbers somewhere along the way. There just won't be any integer models on this one. All the models, the teaching models, are all focused around 6 and 7. Okay? There's 40 multiple choice, 10 short answer, 4 bonus. Other questions that I may help you with? No?
Gauss's method.
Gauss's method. You wanna give me one, or do you want me to just make one up?
You just make one up.
Make it up. Alright, here we go. So, Gauss's method. Since this one has to do, I don't wanna do fractions, but I'm gonna. Let's see, let's do 4.5 plus 5.5, 6.5, and we'll do it all the way up to, we'll do 65.5, 66. We'll stop it there. Will that work? Alright, so Gauss's method is a problem-solving strategy that even littles can use, right, to find the sum of a series. This series starts at 4.5 and it ends at 66.5, and what we don't want our kiddos to do is to try to, somebody actually did it on the midterm, they wrote every single one of them down and added them one at a time. That is not what I'm trying to get you to do here, right? I'm trying to see if you can use Gauss's method. So what's the first step of Gauss's method? Yeah, rewrite it under, so first thing I'm gonna do is say, okay, that's my sum. I'm gonna rewrite the sum underneath it, but when I write it again, what am I gonna do? Flip it around. So this one's gonna be 66.5, 65.5. I'm counting by ones, right? 64.5, all the way down to 5.5, 4.5. So I write it, go in both directions, ascending and descending. Then what do I do? Add them vertically. So S plus S is 2S. Then 66 plus 4 is 70. A half plus a half is 1. So that's 71. You guys agree with that? So if I did it correctly, if everything's lined up right, I should get the same thing over and over. So 65 plus 5 is 70, half and a half, I get 71 again. Does it look like we set it up properly? Alright, so that's what we're checking there. And I actually add those to make sure that I have it set up right. So the reason we do that step is because it then turns this in to repeated addition. Well, we know now as future teachers, repeated addition is just multiplication. It's a whole lot easier to multiply than it is to write all those out and add them up. So I know that 2S is equal to 71. I just need to figure out how many of those 71s there are. Do you agree with me? Okay, so how you figure that out is you pop over to the side. It's always your max minus your min. You take that answer, divide by whatever you're skip counting by, and then when you get that, add 1 back on, because the nature of subtraction, it doesn't count that first number you started at. So you gotta go back and put that number back on. So my maximum here is 66.5. What's my minimum? 4.5. So that gets me what? 62? There should be 62 of those. Now, did I skip count by anything? I just counted by ones, right? So in this case, n is just 1. What did I do?
Would it be 61?
No, it'd be 61. Thank you, Hannah. 66 minus 4 is 60. No, it's 62.
What about the halves?
Well, a half minus a half is 0. And then 66 minus 4 is 62.
Okay, sorry.
No, you're good. Now, let's see if I can get my 4 back on. That's the wrong color. Alright, we good there? Okay, 62. I did not skip count. I counted by ones. From 4.5 to 5.5, that's 1. From 5.5 to 6.5, that's 1. So I'm just going by ones. So that's 1. Then I have to add back on that first number. So, how many 71s are there? There's 63 of them. So we put that 63 in there. Then all we have to do is divide by 2. So, let's see, what would that be? 71 divided by 2 is 35.5 times 63. So 5, 6, 3, 15, 16, 10, 30, 33, 6, 3, 2, 2. How many decimal places? 1. So, it looks like this sum is 2,236. Oops, I don't. And half. Probably should leave it that way since the problem is given to us as a fraction. Excuse me. Does that help? Good. Okay.
Oh, the decimal is there because the half.
Because of that half.
Okay.
Thank you.
Yeah.
I got confused, I was like,
Yeah, it's because of that half. Because think about it, you have an odd number of them. So if you had an even number of them, the two halves would come together and make a whole, and you wouldn't have a decimal answer. But since we ended up with an odd number of add-ins, woo, that word almost left me there. Since we ended up with an odd number of add-ins, I know there's that one extra half left over, which is how we ended up with a half in the sum. Make sense? And you know what we call that? Number sense. Knowing why we get that half. All right, other questions? Yeah, babe.
Okay, so there's short form for like decimals, like the number,
Yes.
and then there's word form?
Yes.
What's the difference?
Short form and word form is entirely words. Can I just make one up?
Yes.
Okay. You want it with decimals?
Yes,
So 42.167. Will that work?
Yes.
Alright, so if I were writing this one, it would be 42 and, remember the word and is where your decimal goes. Then completely cover up the whole number part so that it's gone. Oh my God. And don't touch your iPad when you do it because everything goes away. So cover up the whole number part. Cover up that 42. Now, what is that number? 167. That's the next thing you write. So, 167. Then, with decimals, you gotta give it a last name. So you gotta decide where that ends up. Tenths, hundredths, thousandths. So you gotta put its last name on there. Thousands. Right? So, this one, if you were, I probably should have made the front side bigger for your short word form, but your short word form, the numbers stay numbers, the names get written as words. So the 42 would be a number. Then you would say and 167, and then you would write thousands. So if it was bigger, let's see, 4, 2, 4, 1, 2, 3, 6, or 1, 2, how about that? This one would be 424, give it its last name, 123, and the hundreds place, the hundreds family doesn't get a name, right? And 12 hundreds.
Could it be 1,000? That's what I was thinking, instead of million? Cause there's only one, there's only.
Thank you. That's what happens when I'm making stuff up in my head over here. Thank you. In my head, I think, okay, I'm gonna make this next one have millions. And then I start writing digits, but I don't get to the millions. That's how that happens. Thank you.
So we don't write the last name or whatever per hundred?
Yeah, no, cause it's not 123 hundredths. It's just that that family is just that's our units family, right? Cause of the 3's there, so it gets no family name. Our units family, our thousands family, right? 1,000, 10,000, 100,000, so that whole family has the 1,000. Then if we went on, like I should have, that would be the millions family, the billions family, the trillions family. But the units family here gets no last name.
There was a chart like with that, there's
Mhm.
something else on it, how do you do that? I was kinda confused when I was doing it. I can't remember what it was.
Well, it's all the different ways for expanded notation. So if we keep going with this one, you did word form, you did short word form. I could do 400,000 plus 20,000 plus 4,000 plus 100 plus 20 plus 3 plus 1/10 plus 200ths. There's expanded. Then we go to expanded with place value. So that's a 4 in the 100,000s place, a 2 in the 10,000s place, a 4 in the thousands place, a 1 in hundreds place, a 2 in the tens place, 3 in the ones place, a 1 in the 1/10ths place, and a 2 in the 100ths place. There's expanded notation with place value. Then the next level higher than that is place value with powers of 10. So that one would be a 4 in the 10 to the 1, 2, 3, 4, 5. 10 to the 5th place plus 2 times 10 to the 4th plus 4 times 10 to the 3rd plus 1 times 10 squared plus 2 times 10 to the 1st, 3 times 10 to the 0 plus 1 times 10 to the -1 plus 2 times 10 to the -2. So there's all the different layers of expanded notation from the very beginning, starting 2nd and 3rd grade, where they learn to just decompose it down into its chunks, right? 400,000 plus 20,000 plus 4,000, that's the very basic, and then we add to that as they develop coming up through the grades.
So after the decimal point, it goes to like the negative, the 10 times the negative.
Because, well, 1, the pattern, right, but 2, think about what a negative exponent means.
Yeah.
All that means is that the 10 really should be in the denominator, which is just the exponent way of writing that fraction.
Okay.
So 10 to the -2 power is just the exponent way of writing 1/100.
Okay.
Okay,
Are you gonna have percent of decrease and percent of increase on the test?
that is a good question. I don't remember any of them being in the short answer. I cannot guarantee one doesn't pop up in the multiple choice, but I don't remember percent increase or decrease. anything else?
I think I just have trouble turning the fractions into decimals and decimals into fractions. Not like repeating decimals or anything. I have that, but just like.
Okay, so, let's like this one. Convert 2/11ths to a decimal. So, all we're gonna do, 2/11, you know, is just another way to write a division, which is 2 in the house, right? 11 out of the house. So my question would be, if I had 2 holes, how many groups of 11 can I make out of 2 holes? None, right? So, the first thing I'm gonna have to do, what do we call that whenever we stick a decimal and a 0 on the end of something? Good job. We call that annexing a 0. Annex a 0. We don't say add a 0 because in math class, add has a specific meaning, right? We're not adding 0 here. We're annexing, attaching it on. So I couldn't make any groups of 11 out of 2 holes. So I trade those 2 holes in for tenths. Now I have 20 tenths. How many groups of 11 can I make out of 20? One group. So that uses 11 of those 20. I have 9 left over. Annex another 0. Trade those 9 in for hundredths now. So now I have 90 hundredths. How many groups of 11 can I make out of 90? 8 groups, which uses 88 of those 90. I have 2 hundredths left over that I can't make any more groups out of. So I'm going to trade those in for thousandths, annex the thousandths 0, and I have 20 thousandths. How many groups of 11 can I make in 20? What do you notice is getting ready to happen here? I'm fixing to repeat. I got 9 thousandths left, can't make a group of 11. Annex another 0, so now I have 90 10 thousandths, which ends up being 8 again. So I know that I'm getting ready to have a repetend of what? 0.18. So I know that 2/11 can be rewritten as 0.18 with a bar over both the 1 and the 8 because the repetend includes both of them. So here, if I asked you on the test what the repetend is 1/8. What's the period of this one? 2. Because there are 2 digits repeating. Good job. Did that help, Ashley?
And then
Okay.
for converting decimals back into fractions.
Okay, I'm trying to find one. Like this? No, that's percent. Percent. Well, what if we go to the review? I think there's one on here in there, like a table where you go back and forth, or not? Right there. One like these? So there's a decimal in the middle, right? And you gotta go to fractions to the left. So, 1, and can you read that to me, like teacher style? Remember the other day I told you, for the rest of your lives, you're now done saying 1.36. Because as elementary teachers, we have to teach our kiddos how to read those, right? So we don't shortcut it. We say 1 and what?
36 hundredths.
There's your 1 and 36. There's fraction. 1 and 36.
So could we leave it like that, or would we have to simplify it?
Unless I say simplify, oh, that one's gotta be simplified. Unless I say simplify, you don't have to. So 1, what would that one be? I can do by 4. So 4 times 9, 4 times 25. If I decompose that fraction, what can I do? imaginary 1, which leaves me 1 and 9/25.
Okay, so what would be the percent?
How do you go from decimal to percent?
It would be times 100, right?
Move the decimal 2 times to the right, so 136%. Yep, times 500. So read this one to me. 8.
8,000.
That's where you start with the fraction. And then we can decompose from there, right? 4 times 2, 4 times 250. And that can be 1 over 125. What about the repeater?
So it's 7 repeating, so since it's only one number, you times it by 10.
Oh, is that the one where you like subtract and,
Yes.
Use 709.
Or you could remember the shortcut I gave you that said, if you have only the repetent, nothing else, it's whatever the repetent is over that many nines. So what would that one be, Angela?
Just 709.
Just 7 over 9, which is what I'm hoping you'll remember on that one and go.
so if it was like, 1300s, it would just be 13 over,
13, is
Yeah.
the 13 the repetent? Yes.
so it'd just be 13 over 99,
Yes, ma'am.
and that's like,
That's it.
okay.
If you do the equation like I taught you, that will be your answer. But that trick only works for what? If it only has the repetent. If there are any other digits, any other non-zero digits, other than the repetent, you have to use the equation. Okay? Let's make sure and talk about these repeaters as percents though. You know this one is really 0.777 and it keeps repeating, right? So when I move this decimal to do this one over here, make sure that that percent still has that repeating bar on there. Otherwise, it's not accurate.
Would you want us to, like, put that decimal into a fraction? Like how on the bottom it had like 33 and 1/3%? Or do you just want us to keep at 77.7 repeating?
Either way. So I think what you're saying, Ashley, is you could write that 77 7/9%. Is that what you're saying? Yes, either one of those would be accurate. As long as it's an exact number, which both of those are, yes, that's correct. If you just put 77.7% with no repeater on it, that's not right.
Will you have any of the ones with with more than just the number?
Where we have to use the equation?
Yeah, like where you have to subtract and do all that?
I can't guarantee, there might be one on the multiple choice where you have to do that out in order to pick the correct multiple choice answer. There might be. And I can do one for you if you want, but would you like me to do one now? Yes, okay. Do you want me to just pick one? Is there one on this review that's already there? Probably not. Right there. Represent the following as a rational number, there they are. Okay, so it's 35A on the review. So, first thing, if you recall, is we rewrite our number, stretching it out, right? We need to see it. With me there? Okay. Step 1, I need to move the decimal what? Behind the first repetent. So if I move it behind the first repetent, what did I multiply by?
10 to the power of 3?
10 to the power of 3. I don't want that to be L. I'm gonna let it be. Let's use N. So 10 to the power of 3, or a 1 with 3 zeros, is 1,000. So I multiplied both sides by 1,000. So I have 1,000 in. I have 5347.4747, so on, so on, so on. So step 1, move it past the first repetent. Step 2, in front of the first repetent. So if I moved it in front of the first repetent, that's only a 1 decimal move, 1 place move, which is 1 to 0. So 5, 3, 4, 7, 4, 7. Now, explain to me why I just did all those steps. What was my goal?
To subtract the decimals in a zero.
Yes, to subtract from top to bottom, and everything to the right of the decimal, subtract down to 0 and go away. That's the reason I did that. 7 minus 7, 0, 4 minus 4, 0, 7 minus 7, 0. Because I wanted to get rid of that whole side. So now, 7 minus 3 is 4. 9, 2, 5 equals, what's 1,000 minus 10?
990.
990 in. So now decimal's gone, and I have a simple one-step equation. All I gotta do is divide both sides by 990. And on these, I never tell you to simplify. Okay? So that one is 5,294 over 990. And there might be one of those in the multiple choice. It might not have the extra on there, I don't remember. But those are both the same time, same thing. Is that okay? Okay. All right, there's 2 minutes left. I'll answer more questions, but I know that some of you guys have classes to go to. Anything? Yes?
Okay, this is a question about the binders.
Yes.
In the thing on Google Classroom, did you say leave them in the ASC?
Okay, that goes out to all sections of this class. For you guys,
Just leave it to make sure.
bring it to me,
Okay,
yeah.
I was just making sure.
And that's Monday, correct? 'Cause that's the
Yes,
final
for
grade.
you guys, your final is Monday, so I'll grade you guys some binders on Monday.
Will you be here Fridays? Even though it's.
I usually come in because my husband and my daughter are both at school, so I'm usually here from about, 9 to 1-ish, 9:30 to 1:30, somewhere around there. So I'll be over at my office for office hours on Friday, and my extra room will be open for anyone that wants to come for help.
I have a question.
And then we have the final quiz to do tomorrow.
Okay, yeah, let me tell you guys, the reason you have that final quiz is because that gives me the data on, can you do it with a calculator? Because it covers the same 2 things, right? The final and the final quiz. But that gives me data on, okay, look, she passed the quiz, but she didn't do so well on the paper test. So she's understanding the material, I just need to help her get better at computation. That's the reason I give it to you in both formats. So I get data back, calculator versus no calculator. Make sense? Okay, yes. And the reason I have it due at 5 is so you have time during business hours to get any technical issues fixed.
Okay.
Okay? But, just like every other quiz, if you do it more than 24 hours in advance, there's a 10% bonus. Yeah?
We love that.
Yeah. Bye, guys. Have a good day.